Here's another example, and this one is for making a register. And this register has a number of different things that it can do. So it'll be a 4-bit register with flip-flops labeled D3, D2, D1. And anytime you have a register that has will do different things based on an input, you'll also have a multiplexer. Usually you'll have a multiplexer that goes with each flip-flop. And the output of the multiplexer goes into the flip-flop. We'll have a clock. And most of your registers will be set up this way. Okay, so it has serial input left end and serial output right out, and parallel input W0 through 3 and parallel output Y0 through 3. If the variable named signal is 1, the register should shift values right, using the serial input left as the input for register 3 and serial output right out as the register for register 0. So I have something called signal, and it's a variable, and it is going to tell the multiplexer what to do. And it says if signal is 1, the register should shift values right. Okay, so made them all Q3. So Q3 will go to Q2, and since it's for when signal is 1, it goes into the 1 of the multiplexer. And then coming into D3, I will have left in, that's my variable, and out of D0, I have right out. Alright, now if the variable named signal is 0, the register should load the AND of WI and QI into the ith register. Well, I did not do a very good job of drawing here. Okay, so I have a vectored signal that is W, so I'll have values W0, W1, W3, W2, W1, and W0. And I want to take the AND of that with the Q value. So I'll have an AND gate for each one of these. So it'll be the AND of it and the Q, and that goes into the 0. Whoops. I think I got this one wrong too. Let's see. No, that looked right. Okay, so that would be this ended with that, and then it goes to that. So that was okay. All right, so that that is loading the value, and then it says for the output, it'll be the OR of QI and the variable CMonkey. I couldn't come up with a variable name, and I was looking at these little sea monkeys, the little brine shrimp I have here on my desk. Now this, it ends up that it's not really, it'll always output this the way I'm going to do it. Doesn't really depend on the signal being 0. So I've got the OR of QJ and CMonkey. So I've got my CMonkey variable, and I'll have an OR gate for each flip-flop. And this output is supposed to be called Y. So this would be Y0, Y1, Y3, Y2, Y1, and Y0. And the next thing I'm supposed to do is write the Verilog code. So I will have module register example, and I have Y. Let's see, what all do I have? I have Y, W, left in, right out, signal, and CMonkey. I don't know when I was paused and when I was recording. So here I've listed my inputs and outputs, and then I said my inputs, and then I've listed my inputs there. And then I will have input 0:3 W. I will have output. See, write out is an output, not an input, so I should take that out. Write out, that will probably be a reg, because I'll probably do it in an always block. And I will have output reg 0:3 Y. I think that's it. Alright, then I'll have a parameter n equals 3. I'll use that for a for loop, and then I will have always at pos edge clock, or I did not say yeah, so always at positive edge clock, and so that means I need to make clock an input. Begin. So, and then I will have if signal begin. So that's if signal equals 1. If signal equals 1, I shift right. So the first thing I'll do is I'll say do I not output those values? I guess I need to make Q just a reg. Alright, so then I will say, I'll start by saying Q3 will become equal to left n, and then I will have for n, or I need an integer j. You know what, I'm probably not, I won't use this parameter, I'll just use constants. So for j equals 0, j less than 3, j equals j plus 1. Am I only going to have one line here? I think so. So I said less than 3 because Q3, that was left in. And so I only need to do Q0 through Q2. So I will say Qj becomes equal to Qj plus 1. Yep, that's it. Okay, and then the last thing I need to do is I need to make right out equal to Q0. Now notice with this blocking operator, it doesn't matter that I redefined Q0 right here. It'll use the value that it had at the beginning. That's because I used the blocking operator right here instead of the equals, and so it just the values will be frozen to what they were at the beginning. It won't update them until we get out of the always block. Okay, so I can now end this if, and then I can have else. So now it's if signal equals 0, and if signal equals 0, what did I do? I loaded the AND of WJ and QI into the jth register. Okay, else So I'll have another for loop. I need to begin. For j equals 0, and this time I'll do j less than or equal to 4 because I do want to get all of them in this time. J equals j plus 1, and then I want qj to equal qj and what was my other input? wj. And then I also need to make my output, and I will have so I can have a begin here. Yj is my output. Yj is the OR, so Yj is the OR of Qj just one and Qj or C monkey. Did I put an underscore in there? No. C monkey. And module. Now, one thing that you can see here, I do end up assigning everything, but if I don't get into this block right here, Y never gets assigned, and Verilog or Vivado might have a problem with that. So what I think probably would be best to do would be at the beginning here, assign Y equal to 4b 0, 0, 0, 0. So just so it always gets assigned something. And that is at least approximately right.